Good evening, Samesh. Okay, so I'm Rahul Saha, and in the last class we had discussed about the pKa's, and we had also talked about the Henderson-Hasselbalch equation. We had also discussed the titration of the amino acid glycine. Okay, so very quickly I'll just revise it for you, and then we'll go on to the structures of proteins. Okay, the various types of primary structures. Okay, so now looking at the amino acid glycine. Okay, so I'll give you some specific tips regarding the pKa values. Okay, so what do you mean by real pKa? So pKa is equal to pH when. So we have seen the equation, Henderson-Hasselbalch equation, right? So pKa is equal to pH plus log of A minus by HA, right? So this is what we have been able to see in the Henderson-Hasselbalch equation, right? So when we see this equation, okay, so when A minus is equal to HA, right, conjugate base is equal to the acid, okay, so that time, so log of 1 is 0, that time what will happen, pKa equals the pH. That is the time when it is buffering maximum, because suppose you have this specific compound, so it is CH3CO minus its conjugate base, right, A minus. So if this is equal to this, so if I am adding any H plus in the system, this will act and form, you can say, CH3COH. Then it will try to act as a buffer, it will act as a buffer and not let the pH drop. Okay, not let the pH drop whatsoever. That is the meaning of pKa, means at that point of time, if you have seen this graph, I'll just show the graph to you here. Titration curve of glycine. Okay. So titration curve. So if you see this graph, okay, this one, just look at this graph. So when we look at this graph, what we see is, good evening Pratham. So what we see is, after looking at this graph, so we have got two pKa's. Okay, one pKa is 2.35, that is pK1, that is the pKa of the acidic group, and this is the pKa of the basic group. Always remember, okay, pKa of the acidic group and pKa of the basic group. Okay, so we have got two pKa's. So in this region here, right, let's start with pH 0. So I'll tell you the real trick, how to, not the trick, the real method, the real conceptual method, how to know at which pH what will be the state. So let's start with pH 1. Let's suppose pH is 1. Now for this thing, we are pKa 1 means what? Suppose this is S3N plus, okay. So this is the deuterionic stage. This is the simple one. Okay. So this is pK1 or pKa1. This is pKa2 of the second one. So pKa1 is given to be 2.35, pKa2 is 9.78. Okay. This is 2.35. This is given to be 9.78 experimentally. Means at this and this pH, the resistance to changing the pH will be maximum, means they will be buffering maximally. Okay, they will have most buffering effect, meaning that if you have a pH of 1, let's start with pH 1. keep this solution in pH1. What will happen? pH1 means a lot of H plus ions are there. Lots and lots of H plus ions are there. Okay. So what will happen is, from this deuterionic stage, pH1 is lot of H plus ions. So when pH is less than pKa, so we are considering this pKa here. This is too much, too high. So we are considering first this one. So pH is less than pKa1. That time what will happen is, too much H plus is in the system, so H plus will protonate it. So protonation. Okay, protonation of the molecule means once the molecule gets protonated, okay, what will happen is, now because the pKa1 is 2.35, okay, and the pH that I have taken is 1, so once the molecule is protonated, what will happen is the protonation will completely happen, okay, and the simple molecule, okay, will become like this: H3N plus protonation. Okay, suppose it was like this in the beginning. In the beginning it was like this, NH. Now after protonation, what it will become is H3N plus protonation here, CH, COO minus. Okay, so this is what it will become after, sorry, not CO minus, so protonation will happen here also, COOH. So half of the molecules, okay, so mostly you can say the molecules will be in this state, H3N plus CHCOH, because it has been protonated. This is completely protonated. The CO minus has been protonated because there are too many H plus in the system. A lot of H plus is in the system. So questions like this, right, can be asked in NEET examination. When pH is less than pKa1, what will be the state of the molecule? What will be the state of the molecule and the charge of the molecule? So what is its charge right now? 100% of molecule are in this stage at pH1. So charge is 1 positive. So positive 1. That is the charge. First question answered. Okay. At pH1, which is less than pKa1, which is 2.35, the molecule is completely protonated. The charge is 1 because we have net charge 1. Okay. So this is the thing here. So next up, when we equal pH to pKa1, what will happen now? So if we equal pH to pKa1, so pKa1 is regarding this, so half will be protonated, half will be deprotonated, because we do not have too much H plus ion, but we have, you can say, enough H plus ions that half will be protonated. If it is less, then everything will be protonated. But since 2.35, okay, pH is equal to, suppose, pKa1 now, pKa1 is 2.35, okay. So when pH is equal to pKa1, what will happen is, you will get this state. Half will be completely protonated, but half will be like this. HCO minus. This will not be protonated completely because too much H plus is not there. It is equivalent to pKa1. So now what is the net charge? The net charge of this one is plus 1. The net charge of this is, you can say, not complete thing. Okay, it is not plus 1. It is still 0. So I can say that when we take the average will come to be plus half. The average will come to be plus half. Okay, like that you can say the average will come out to be plus half charge. Okay, so pH equal to pKa will become plus half. Okay, so now when pH increases pKa1, now pH more than pKa1, pKa1 is again of COH group, 2.35. Now when it has increased means H plus ions have really reduced. Okay, H plus ions have really reduced. Now all the ions will be like this. Okay, you will not have fully protonated state. Okay, so this is the deprotonated form. It is taking away proton from the COOH group, so it is like this only. All the ions will be in this state. Okay, all the ions will be in this state, that is known as zwitter ion. Zwitter ionic stage. That zwitter ion here is pH 6.06, you can say. Sometimes it is 5.97 also. So pH of 6.06. For glycine, all the molecules will be like this. So net charge is plus minus 0. Net charge is 0. You can see the trend. Net charge was plus 1. When pH was less than pKa1, net charge was plus half. Okay, of all the molecules. When pH was equal to pKa1 and the net charge now is completely 0, which is at the isoelectric point. This is the isoelectric point Pi. Okay, now moving on to pKa2 here. Now we are reaching pKa2. Now when pH, you can say, is less than, okay, pKa2, again you will be having, you can say, this kind of state, that is the protonated, you can say deprotonated state. Okay, let me throw, and then it freezes and it is durable as normal rope. Okay, good evening Gayatri. So the thing is, there are liquids. Okay, it has been discovered, such liquids have been discovered. You can say these are, you can say, in the particle physics they come in. Okay, particle physics and matter, you can say synthesis physics. Okay, they come in. They are really high order. You can say the dynamics are high order. Okay, means you will need to understand the vibrations of the solid states. There is a chapter known as solid state chemistry in class 12th, I think. Yeah, in class 12th. When you understand that chapter, okay, then you will be able to understand Spider-Man web shooters. That one you were talking, that he is shooting the web and it is freezing. It is, how will it freeze in the web shooters? It is freezing after throwing, you are saying. Okay, I got your question. It is coming out as a liquid, and when it is reaching the, you can say, the thing is, when it is reaching the air, it is getting frozen, right? And it is durable as a normal rope. Okay, so Spider-Man web shooters we are talking about. So that I understood. So there are materials which are being made like that. Okay, there are materials which are being made like that. Okay, so there are those things. Okay, so the tensile strength is very high. Okay, so but the thing is, those matters or those types of matter have not been produced in real life. There are work going on. Okay, so you have work going on, and then you need to apply. Yeah, I understood. Changing the state, there are various work going on, so you need to calculate the force net. Okay, then del Py by del T you need to know, that is force equal to mg. So those things you need to, I think you know it already. So then you need to, you can say, convert it into megapascals and see what is the tensile strength. So those things are there. Okay, but again, so if you talk about the what is called web with real materials of the same size, which is available on Earth. Okay, so the maximum tension, okay, based on their nature would be like this. If I say steel cable, so steel cable would take tension of 6.503 newtons. If you take nylon rope, it is very very high, it has high tensile strength, it takes 235, you can say, newtons. And if you take the spider silk, okay, the spider silk originally, so spider silk has a tension of 3.142 newtons. This much tension it can bear. The real spider silk I'm talking about, not the Spider-Man one. The spider silk, which is known in biology. Then if you take carbon nanotube, very very effective. This can replace your silver. This can come the closest. If you know about nanotubes, okay, if you have learnt about nanotechnology somewhere, okay, there is a branch known as bio-nanotechnology also. Okay, you have the buckyballs, known as fullerenes. Okay, so carbon nanotubes are there. They have very high tensile strength, 1.98 into 10 to the power 5 newtons. So you can use this, but this is still in the, you can say, state where they are being produced, but they haven't been mass produced till date. But there is a way that you can go through it. Like you can try to emulate Spider-Man later on. Like after 10 years, you can use carbon nanotubes, and when they are better engineered, okay, so it can do it. Okay, it is you can say proper candidate. Okay, so that is there. But the thing is, you need to calculate a lot. Like Spider-Man, it shoots the web, and first of all, it goes till 20 to 30 meters. Means you need to have a velocity also. From where will you get that energy? Like after you are shooting, so it is going from building to building, right? So those things you need to be careful about. Like consider those things also. Okay, so that is there. So just keep those things in mind. Otherwise, it can be produced. It can be produced. It's not like that it cannot be produced. Okay, I'm not. The world can do it. Okay, the physicists are able to do it. Okay, so there is no problem as such. Okay, if it cannot happen, it can happen. Okay, so now when we come to pH of, okay, yeah, Spidey can be made. Okay, buckyballs, those are known as, you can say, fullerenes. Okay, fullerenes, if you see. So fullerenes, just check in Google that I wrote. Okay, you will get to know a lot about the carbon nanotubes. Okay, so it is possible, but not now. Give it 4 or 5 years. Nanotechnology is taking a boom, so it will be possible. Okay, so when you are going up, okay, in the pH, when you are going up, so when you have reached pH of 9.6, okay, when you have reached a pH of 9.6, okay, which is the pKa2, it is the pKa2. Now what do you have is, you will have again protonation, then deprotonation. Half will be protonated, half will not be protonated, because the pH is not that high. Means group number 2, okay, group number 2, H3N plus CHH, this one, okay, and you have this thing CO minus. So this will be the state when you have pH less than pKa2. But when you have pH equal to pKa2, okay, pH equal to pKa2 means now too much, like you have H plus ion but not that much. Okay, so some of the H plus ions will leave this and will protonate OH minus ions to make H2O. So we will have equal concentration of this thing. Okay, and when pH exceeds pKa2, okay, suppose you reach 11.6, a very very high pH, means a lot of OH minus is there. Okay, a lot of OH minus is there. Now what is the charge here? Okay, so the charge is not great. Okay, the charge is not great at all. This is 0, this is -1, so this is now the charge is -half here. At pKa2, the charge is -half as per the NEET examination. And then when you go to highest pH here, so this will, whatever was not deprotonated will be deprotonated, because pH is high, OH minus is high, and you need to reduce the number of OH minus ions. Okay, so everything will become like this. So net charge will become -1. Okay, so you can see the trend. It started from +1 to +half, Zwitter ion 0, pH less than, +1 means when pH was less than pKa1, +half when pH was equal to pKa1. Here it was pH less than pKa1. Okay, here pH equal to pKa1. Okay, this is the Zwitter ion. This remained in the Zwitter ionic stage, means it was pH less than pKa2. Okay, now again here you will get -half, which is pH, you can say equal to pKa2. Then you are getting -1, which is pH greater than now pKa2. So this is the charge distribution in the amino acid when you keep on increasing. Okay, this is suppose pH of 1, this is pH equal to pKa1, means pH of 2.35, this is pH of 6 isoelectric point. Okay, this is so this is your pH equal to pKa2 is how much? 9.6. This is pH greater than pKa2. This is, I am taking it as 11.6. So if you know this table, right, pH, pKa, any question from NEET examination, you can solve just like this. It will be in your fingertips. Okay, always remember that pH, when pH is less than pKa, okay, when pH is less than pKa, that is pH is very low, so too much H plus will be there, so it will cause protonation. So it will cause protonation of the compound. And when pH is more than pKa, means you have too much OH minus ion, so it will cause deprotonation. Okay, and when it is equal, so half will be protonated, half will be deprotonated. Okay, when pH is equal to pKa, always remember, we will be saying protonation or protonated will be, or I will just erase it and write that, okay, for you to have that trick with you. If you forget that, you can say concept also, you can know this thing, that when pH is less than pKa, protonation will happen because of too much H plus ions, protonation of the compound. Okay, when pH is equal to pKa, half protonated and half will still be deprotonated. Okay, because too much H plus is not there, it is equal to the pH of pKa1. When pH is greater than pKa1, and too much OH ions means pH has risen, so deprotonation of the compound to neutralize that OH minus ion, or deprotonation, I should be saying. Of the compound. So this is what keeps on happening in our body all the time. So this is the golden rule. Always know this golden rule for the rest of your life, because you have taken biotechnology, you have taken biology both. So you have the option of becoming a scientist also later in life. Okay. So this one is, Gayatri, this one is regarding the, you can say, the titration curve, which comes in only NEET examination. They won't ask you titration curve. Okay, this is from the biomolecule chapter, especially in the biotech thing, but you have the titration. Okay, and in NEET examination the titration is not asked. Okay, titration will not be asked. but they'll tell you, okay, what they'll ask you is, they'll ask you the pH, okay, they'll say that the isoelectric point is there. What is the charge in the isoelectric point? You will say net charge 0. But then they'll say, if I increase the pH, now what is the charge on the amino acid? Okay, so how will you find out? You cannot mug it up. If you increase the charge on the amino acid, okay, suppose you increase the pH, glycine, if you put glycine at 11.6, if the PMT question comes, glycine amino acid is put at pH 11.6, now what is the charge? If this is the question that is asked in PMT or NEET, okay, 4 options are there: +1, second -half, okay, third is -1, fourth is 0. Correct answer is -1, but I cannot ask you to mug it up. Okay, mugging up is not the case here. In biology, nothing shall be mugged up. So that is how it is proved that -1. I proved it to you right now that minus 11.6 means the pH is more than the pKa2. pKa2 is 9.6 for the group amine. Okay, so complete deprotonation will happen. So you will be having like this. This will be the state of all the molecules. So what is the net charge? You CO minus -1. That is the correct answer. So in order to solve this question, you need to know this concept that I had taught. Okay, if you want to understand, if you want to mug it up, then I told you the mugging up also. Mugging up is this one that I just told you, that pK, pH that I made the graph, or simply I wrote like this, right? +1, then +half, then 0, then -half, -1. Here I wrote pH less than pKa1, then here pH equal to pKa1. Okay, this is again pH less than pKa2. This is pH equal to pKa2. This is pH greater than pKa2 of the amino acid. We are taking here glycine. So this is the charge, this is the state, okay. And what is the pH here? Here I have taken pH as 1. Here the pKa1 is 2.35, so pH is 2.35. Here isoelectric point experimentally 6.06. In some books also 5.97 is given. Here it is 9.6 pKa2. Here I have taken an arbitrary pH 11.6. So this is how you can mug it up. Okay, but the thing is, if it slips from the head, you are a gone case. Okay, that's why I told you or explained to you the entire concept behind it. Okay, that how the thing happens. And in last video also I had described the concept, because I don't want you to mug it up. Okay, this is, you can say, biotech plus biology combined I am taking for the NEET examination, because I am taking the NEET examination, what is called the NEET classes for you. So instead of explaining there, we are wasting a lot of time there, because I'm explaining the concept. So NEET worksheet I have made. Okay, so the thing is, when I have to explain there again and question solving is done again, okay, so what happens is lot of time is wasted. So we have only completed you can say 10 questions in one chapter till now, right? Because I have to explain everything. So what I'm doing is I'm completing the entire concept, because your entire aim is to clear the NEET examination, right? You want to top like somebody, you want to become a doctor. So the thing is, have the concept, and then when we get stuck in some of the classes in the worksheet, then we can directly focus on the questions rather than the concept here. I've also asked the management to give me specialized NEET, what is called extra classes, like one concept based class, then after that we'll solve the question. So they are thinking about it. So maybe that will be approved, that first of all we'll go with the concept of NEET only, because concept of NEET is little bit, like you can say, in depth. It is not only mugging up the NCERT, so you have to go in depth, like you have to understand the concepts. So conceptual NEET class, then we can easily go for the, you can say, solving of the questions also. So that will be much better. I have talked about it. So let's see from when it starts. So in the meanwhile, what I'm doing is, whatever topic I'm getting, whatever very important topics, not all the topics, like this protein one is very important in biochemistry. I've seen a lot of questions being asked, so I covered, you can say, as per the biomolecule worksheet that we will be doing. Okay, from the next week. This week we'll be completing the kidney chapter thing. Next week I'll be sending you the biomolecule worksheet. Okay, so you will see there are lots of questions like this. Okay, okay then. So the protein part is done. Okay, now we are coming to the biotech part. This was also the biotech part only. So now the biotech part is structures of the protein. Okay, structures of protein. So a protein is like a polypeptide chain. Okay, that I had explained to you, polypeptide chain. And polypeptide chain means it has to keep on folding again and again. Okay, so once you fold it, okay, what it becomes is, it becomes the primary structure. Okay, then secondary structure. Okay, then super secondary structure. Okay, but these things will not be in your course. From super secondary is not in your course. Okay, just I am writing the name only. Super secondary, then tertiary, then in the end you will be having quaternary structure of the protein. So the protein that I am showing you here, wait, I'll just show a protein structure. Okay, quaternary structure of the protein, that is how it looks in the real world. Like in our body, those proteins are functional. Look at this image, quaternary structure of protein. Okay, so look here, this will solve all your queries. This is the primary structure, this is the polypeptide chain. Like you have this polypeptide chain here, C2N, N2C, right? Then you have the alpha helix here, the beta pleated sheet. These two are in your course. These are secondary structure. These two are in the, you can say, ICSE, you can say biotech course also, alpha and beta sheet, ICSE biology course also, but alpha and beta sheet will not be there in the simple biology course of NCERT, and but alpha and beta sheet will be asked in NEET examination. So Gayatri, you shall also study it, because it is not in NCERT if you are from CBSE, okay, but it is in ICSE book, it is in ICSE biotech book, okay, and it comes in NEET examination. These two only alpha and beta sheet, nothing else. This is tertiary structure, and in the end when you keep on folding it again and again, super folding, they assume quaternary structure. So any protein which has been found in the body in working state, like any enzyme, any hormone, any globular protein, any fibrous protein, so they are in their quaternary state. If they are in their primary state or secondary, they are functionless. So that is how they change states. Like we have solid, liquid and gases. They have primary, they'll fold once, they'll become, you can say, secondary. Super secondary is not given in this figure. Then they'll become tertiary, and in the end they'll become quaternary. Quaternary structures, you have talked about enzymes, then these quaternary structures will only have the active site. Okay, this primary, secondary and structures never have active sites. Okay, that is the theory behind it. One question in NEET, I'll tell you, it came. Okay, the question was, there were given two proteins, myoglobin, okay, and hemoglobin. So myoglobin is present in muscles, and oxygen binding protein, hemoglobin is present in blood. Both bind to you can say oxygen, myoglobin and both. So this is found in muscles. Okay, I'll teach you in the next class. This is found in blood, myoglobin, hemoglobin. Okay. Now it was found, it was asked in NEET examination that which of the two will assume or will attain quaternary structure. Okay, which of the two will attain quaternary structure? This one, both, or none of the above. These were the four options. Okay. Now how to solve this question? Very easy. Very easy way to solve this question is, know that how many polypeptide chains make one protein. How many polypeptide chains make one protein? That's all. So there are proteins which are made up of various polypeptide chains, multiple, more than one. There are proteins which are made up of only one gene, therefore one polypeptide chain. So we know that hemoglobin is made up of When we talk about hemoglobin HP, here I'm talking about MB. So hemoglobin adult one is made up of 2 alpha chains and 2 beta chains. So beta gene is and alpha gene are different. So number of polypeptide chains is 4 polypeptide chains. This is made up of only one polypeptide chain. So when you are a solitary polypeptide chain, a single polypeptide chain, you can take secondary conformation. Okay. After that, you will attain supersecondary. Okay. Then you will fold more and the molecule will attain tertiary conformation. But it cannot fold more and attain quaternary structure if it is made up of only one polypeptide chain. That is the rule. And when it is made up of 2 or more polypeptide chains, then it can attain quaternary structure. So the answer to that question is hemoglobin. But again, you cannot mug it up. This is the rule. Okay. Mugging up is very easy in biology. But understanding is the core part. So why quaternary? This is the reason why it is quaternary structure. Why it has been able to attain quaternary structure and why myoglobin cannot attain quaternary structure. The reason is if you are made up of more than one polypeptide chain, means at least 2, you will attain quaternary. Only 1, you will attain maximum the tertiary structure. That is the rule here. Okay. So next is we will be going on to the alpha helix, which is there in your course. Okay. Especially the biotech ones, the alpha helix. So alpha helix, when we look at an alpha helix, okay, so alpha helix, I'll just show you, it looks like this. Alpha helix. It is like this. You can see here. It looks like this. Okay. This is what it looks like, or this is what it looks like. Alpha helix. Okay. Alpha helix looks like this also. Okay. So these are the diagrams of alpha helix, various alpha helix. Okay. So what happens is alpha helix is a single polypeptide chain first of all, and which is getting or which is trying to fold upon itself. Once it is trying to fold upon itself, what it is having is the alpha helix structure repeats every 5.4 angstrom. That you can see, it is repeating itself. You can see every 5.4 angstrom it is repeating itself. Okay. Number one thing. And alpha helices have how many amino acid residues per turn? This is one turn, another turn. So they have got 3.6 amino acid residues per turn. Okay, means that you can have 10 turns. Okay, so if you have 36 amino acids, so 3.6 residues per turn I told. So if you have 36 amino acids, you can make how many turns? 36 by 3.6, that is 10 turns. So if you have 36 amino acids, you can make 10 turns in an alpha helix. Okay, that is there. And the separation of the residues, okay, the separation of the residues along the helix is how much then? Between the two residues, how much will be the separation? You can say the pitch of the helix is 1 mark question, 5.4 angstrom. Okay, and 3.6 amino acids are there per turn. So 5.4 by 3.6 if I do, I'll get 1.5 angstrom. Okay, so that will be the distance between the two amino acids. That is known as rise per residue. This is also known as rise per residue. Number of residues per turn, okay, is 3.6. The pitch of the helix or the length of the helix is 5.4 angstrom. Here 3.6 amino acids are there. What is the distance between the two? 5.4 by 3.6. 2 amino acids, that will give you 1.5 angstrom. Okay, that is known as rise. This length is known as the pitch. Okay, 3.6 amino acids are present and that is rise. Okay. Now you will see here these bonds. These bonds will be given in your book also. These bonds are there. These are nothing but hydrogen bonding between the two amino acids, but not any two amino acids. Okay, they happen roughly between 4 residues away. So if this is the first residue, so 1, 2, 3, 4, then fourth residue, first to fourth. Again, this is the first here, 1, 2, 3, fourth, like this, first to fourth. Like this kinds of bonding happen every leaving 4 residue. Like if you have hydrogen bonding here, okay. So if you are having hydrogen bonding here, so there is residue here, so you will not have here, not have here, not have here. You will be having with the fourth residue here. Okay, that is known as N plus 4. If this is the hydrogen bonding here, next will be 1, then 2, then 3, then 4, like this. So like this you have hydrogen bonding leaving 3 residues. Okay, N plus 4, that is the way it goes regarding the hydrogen bonding. Okay, so it is written as Ni plus 4. That is how it is written as. So this gives a very regular and stable arrangement. Okay, and the peptide planes are roughly parallel with the helix axis, and you have a specific dipole within the helix. Okay, meaning that all the CO group in a peptide bond, what you have, right? You have CONH bond, right? You have this bond or not? Okay. CONH bond you have, right? So this CS3. So this is the CONH bond. This is the peptide group, or sorry, the peptide bond, which I told you is partially double bonded, right? Peptide bond, because its bond order is less than that of the first order but greater than that of the second order bond. So less than double bond, greater than double, you can say less than single bond, less, or you can say greater than the double bond. So it is somewhere between double and single, so it has a partial double bond character. Okay, so all the CO groups, okay, here COH means what? If I break it down, I can write like this. So all the CO groups, they point in the same direction, and all the NH groups, if I break this down, then all the NH groups, they point in one direction. Okay, so you can see here CO means O is more electronegative, it will become minus, this will become positive. Okay, so if I show you, you can see here it is the negative, means the negative end has lots of CO group. This is has N to C. So N to C terminal it goes, any protein. Okay, so means the N terminal is positively charged, C terminal is negatively charged, like that. Okay, so it is a general thing, because CO in the end it will end with CO group only and begin with this. So the first one and the last one, so last one will attract, you can say, electron cloud. So it will be a dipole, negative. Partially it will be a positive dipole, because it will attract electron cloud again. This is more electronegative than H. O is more electronegative than C. So it will have a partial negative charge, partial positive charge. So you know that dipole is denoted like this. So it's a partial dipole at the end, and we have amino acids from N to C. Okay, so this is your everything regarding alpha helix, right? And little bit if you go deeper, okay, for neat level, okay, so what happens is there is always some distortion in the alpha helix, you will be seeing, you can say, distortions. That is, they are curved or distorted somewhat compared to the standard model. Means little bit of distortion is, little bit curving is there, you can say little bit they are bent like this, okay. So this distortion happens due to the amino acid proline, because proline is the only amino acid in the biomolecule chapter which has an imino group, not amino group, okay. So it is very bulky. Proline is very bulky, okay. If I show you the structure of proline, you will understand it much better, okay. Proline structure, you can see here it has got imino group, okay, not amino group. If you see the structure of proline, okay, so this is your proline. See here, this is the imino group. There is COH but NH only. Imino group is the proline. You can see here, leucine, proline, glycine. You look here, this is the imino group. Very strange. Doesn't have this free amino group. This has free amino glycine. Leucine also has free amino, right? But proline, look here, it is not like NH. It doesn't form NH3 plus, okay. In the zwitterionic stage, this is like a benzene ring, a cyclic ring. This is known as an imino group. This is special group. So it causes steric hindrance. It is very bulky, right? That cyclization is very bulky. So that is what, when you accommodate proline in a specific or in a polypeptide chain, you distort that chain. Little bit of distortion while bending, little bit of distortion happen in the, you can say, alpha helix, okay. That is the thing, okay. And wherever there is bend, you have glycine. Mostly you have glycine, because glycine is the smallest amino acid. So bending is very easy. So that is the maximum. Proline causes distortion, okay, due to its imino group, which is a bulky cyclic group. And glycine is the smallest amino acid, causes sharp turns, okay. Because of its small size, very easy to cause turn. So sharp turn is taken like this. These turns can be easily taken by accommodating glycine, okay. So these questions can be asked at max in NEET examination, not more than that in alpha helix, okay. Now if you see or have beta pleated sheet, okay, so when we talk about a beta pleated sheet, so I'll show it to you. Then from the next week onwards, we'll start the topic in your biotechnology, a new chapter, okay, from next week. So beta pleated sheet, I think you have genetics in your course, so we'll be starting that, okay, from next week. Beta pleated sheet, okay. So this is how a beta pleated sheet looks like, okay. This is how a beta pleated sheet looks like. I can show you this also. This is much better. Let me open this and I'll answer everything here only. Okay, look at this image regarding the beta pleated sheet, okay. Beta pleated sheet will only happen if you have two polypeptide chains, okay. That is, then it will assume the beta pleated sheet. This is parallel beta pleated sheet, okay. Sorry, this is the anti-parallel. One is going N2C like this, another is going N2C. So both have opposite orientation. This is anti-parallel, okay. Beta pleated. Beta pleated. So mostly it is a series of anti-parallel sheets, okay, anti-parallel sheets. So one is going from N to C, one is going from like this N to C. It is always N to C, but orientation is opposite. This is known as anti-parallel arrangement, okay, anti-parallel. This is known as parallel arrangement. If both are oriented in the same way or in the same orientation, this is parallel arrangement, okay. what happens is the anti-parallel one, okay, the anti-parallel one are more stable, okay. So in among two residues the span is of 7 angstrom. The 7 angstrom is the span. And why it is known as pleated? Because it is like this, like this. The peptide bond is not straight but little bit bent, okay. So from looking from this angle, if you look from this angle, if you put eye here three-dimensionally, it will look like pleated, okay, and it gives a sheet-like appearance. That is why beta pleated sheet, okay. So if I get to show you that image, okay, it is like this. You can see little bit of, you can say, bending is there, okay. The bonds are not completely, you can say, stretched out. So if you look from here 3D angle, if you are at this point looking this way, okay, so you will see these bendings, that is pleated, and they give sheet like appearance. That is why they are pleated and they are called a sheet, okay. Now come here, you have 7 angstrom, okay, which is the distance between, okay, the repeated units of amino acids, okay. So they are the two polypeptide chains. Now the anti-parallel, you can say, beta sheet is more stable than the parallel one. Anti-parallel is more stable than parallel. Can you tell me why? Looking at the structure, anti-parallel is more stable. Yeah, that is true. F is greater than O greater than N. That is, you are completely correct, okay. So I am saying that compare it with that thing, N and H at one pole, which is more electronegative, N or H? N is more electronegative than H. Another electronegativity pole, you have C and O, which is more electronegative. O is more electronegative than C, okay. So among the highest electronegativities, you have highest is fluorine, then oxygen, then nitrogen, okay. That is the rule. You have a Pauling scale here, that is known as Pauling scale of electronegativity, okay. Okay, no issues. Good, Gayatri. So that you remember, that is good. That is a good trick also. F is highest electronegativity. Yeah, easy to remember. Okay. So I didn't tell you that because I was comparing NH. Here it was NH2. So there is no use of comparing. Here you have C and O. Okay. So if I had to compare between C and N, then I would be, or O and N, then I would be sharing this thing. That's why I skipped that. I just told O is more electronegative than C here, N is more electronegative than H here, okay. But this trick is also good one, and I also came to know about this trick in my class 11th. My teacher also told me the same thing, right? So Pauling scale is there. Just Google the Pauling scale if you want to know about electronegativity in detail. It's a very good thing. Have you learned these rules? One is the rule is, you can say, have you learned this rule, Gayatri? Fajan's rule. Fajan's rule is there. Then you have what is called the ionic property in covalent bond, then covalent property in ionic bond. Both you have, right? So if you have studied the bonding chapter, yeah, so you can apply that rule also, okay. So that is good. So in the last thing, just look at this structure, Gayatri, and tell me why a parallel beta sheet like this one, which have both CC orientation in the same, NN in the same, is unstable or more unstable compared to anti-parallel beta sheet. Just look at this diagram and tell me. Very easy. You can see here in the parallel one, the hydrogen bondings are not straight. They are haphazard hydrogen bonding. Whereas in anti-parallel, the hydrogen bonding are completely straight, right? Straight hydrogen bonding, this dot 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 dot. That is intermolecular, between two molecules, between the two polypeptide chains, you have hydrogen bonding, right? That is completely straight. So the answer is written in NEET examination as the anti-parallel beta sheet is more stable, okay, it's more stable than parallel beta sheet. Why? Because the antiparallel beta sheets have collinear hydrogen bonding. Have collinear hydrogen bonding. Okay, so that is the reason, because the hydrogen bondings you can see are all straight hydrogen bondings in antiparallel, where they have opposite orientation. That is why antiparallel beta sheets are more stable than parallel beta sheets. This is the maximum that can be asked in NEET examination. Okay, so we have completed the entire protein part. Okay, so from the next class in biotechnology, I'll be beginning the genetics part, because genetics is there, I think, in your course. So we'll be beginning that part. Okay, it is a very interesting topic, molecular biology related to DNA, related to how you become what you have become. Okay, that is why do are you, why do you have so many diseases like congenital, like sickle cell anemia, hemophilia, leukocyte adhesion deficiency, severe combined immunodeficiency? So many congenital diseases are there. So why do we have those things? Why are we not tall as our dad? Why are we not fair? Why are we not, you can say, having black, you can say, iris, or you can say pinna is not, you can say, of the shape that you like? Okay, so those, all the phenotypic things will be answered. Okay, so I hope you are able to comprehend the lecture. If you have any doubts, then we can discuss in the tomorrow's practice class or in the doubt class. So tomorrow I have kept doubt class from 4 to 5 p.m. open Google Meet. Okay, so I'll be sharing the Google Meet link. You can bring any of your doubts and we will try to make biology more and more interesting. Okay then, thanks a lot. Let's meet you in tomorrow's NEET class and in the doubt class.